Hey guys, Mr. Milton here. Today we're going to talk about inscribed angles. At the end of this video, you should be able to identify both types of inscribed angles, and you should be able to use inscribed angles to find missing measures within circles. Okay, move this up so I don't have to move it again. Nope, I will have to move it again. Okay, an inscribed angle is an angle formed by two chords whose endpoint is on, whose vertex is on the circle. Okay, and the measure of the inscribed angle is half of the measure of the intercepted arc. So, in circle O, notice that we have ABC, angle ABC as the inscribed angle. I'm just going to call it angle B. Okay, it's an inscribed angle. Its sides are chords of the circle, and B is on the circle. The intercepted arc, or the arc that's in between the angle, is arc AC. See, this is the intercepted arc. Okay, so now referencing what an inscribed angle is and how we find its measure, it says that the measure of angle B is 21 degrees, or if the measure of angle B is 21 degrees, find the measure of arc AC. So they're asking us for measure that's just talking about an angle, not a length. Okay, so B is 21 degrees. The inscribed angle is half of the measure of the intercepted arc, and so since we know this is 21, that arc must be double. So arc AC then would be 42. Okay, given another hypothetical, if the measure of arc AC, so I'm going to scratch this out, if the measure of arc AC was 70, then we know that the arc is double the inscribed angle. So if this is 70, the inscribed angle is half of that. Angle B would be 35 degrees. Okay. All right, so let's look at a few more examples of that here. Down at the bottom half. So, they ask us in our first problem to find the measure of angle ADB. Important here to identify which arc is being intercepted between ADB. Might be helpful. See what I'm doing is extending that line, those chords, and then that arc between the chords is the intercepted arc. So AB is the intercepted arc, AB is 76, so this would be half of 76, which gives us 38 degrees. So we find out that angle D here, ADB, is 38 degrees. Okay, then we want to find the measure of arc DC. So again, DC here, we probably want to go and find out which angles, what angle is inscribed there. And so we see angle B. Angle B is 45 degrees. Okay, that is half of the arc it intercepts. So here we can say 45 times 2 and gives us 90 degrees. Arc DC is 90 degrees. Okay. Oops, and none of that was on the screen. Look at that. Luckily, it wasn't high level math. If you're following along audibly, then it should make sense. Alright, number 2. Same kind of thing. They gave us the measure of an inscribed angle. PRQ is the inscribed angle. Okay, this question is asking us to find the measure of POQ, which in circle O here is the central angle. So while we can't go from the inscribed angle to the central angle, we can get pretty close. We're going to go from the inscribed angle to its intercepted arc. Okay, its intercepted arc, here's PQ, it's 124. Okay, because the inscribed angle is half of the arc, so we'd say 62 times 2 to get 124. And since this arc is 124, the central angle is 124. We know that from our first lesson, really, that the central angle is the same as the arc it intercepts. Okay. And then finally, if you want to take some time and pause the video and try to do it on your own, do that. Okay. We're going to find the measure of arc CD. CD? Yes, okay. So, arc CD here, I see a few different lines that intercept CD. And so here, I'm going to extend some of those lines. And if I could find angle A, or if I could find angle B, both of these inscribed angles intercept arc CD. So I'm going to use the measures inside of my triangles to see what I can find. So I'm given that this is 32 degrees. Okay, and here I notice vertical angles. Vertical angles being congruent, because we know that this is 85. So 32, 85, that gives me 117. 180 minus 117, that's 63, isn't it? Yes, it is. Gives me 63 degrees. Okay, so I know that this angle, 63, is the inscribed angle that intercepts arc DC or CD. Okay, so I can say that arc CD is double that angle, which gives me 126. Okay, so there we go. If you don't have your sound on, listen to the sound. Makes it a lot more. I know that there's not a whole lot of writing math here, but the reasoning's been explained audibly, so please make sure you're listening to this. As always, I guess I should say. Alright, so here we go. Some more examples, seeing the problems in a slightly different way. Here for number 1. We are trying to now use inscribed angles to solve for variables. First one, they want us to solve for A. A is this arc PT. Okay, in this arc PT, I notice an inscribed angle, angle Q. Angle Q is 60, and so I can do 60 times 2, which gives us 120. That arc would be 120. That means A is 120. B is an inscribed angle here, and notice that it intercepts this arc that contains A, which we already know is 120, and arc ST, so we'll say arc PS, which is 120 plus 30, which is 150. So here we can find that B should be half of the arc it intercepts. The arc it intercepts is 150. Half of 50, or 150, sorry, gives us 75. For number 2, we are given an arc here and its inscribed angle. Now we don't know the value of either of these, and we don't have to for this problem specifically. We do know their relationship. The inscribed angle is half of the intercepted arc. Inscribed angle is half of the intercepted arc. And so, another way we can say that is 2 inscribed angles equals the intercepted arc. And then we're going to use that to set up our equation. 2 times the inscribed angle should give us the arc. Okay, and so now we're going to set that up and solve it. 6x plus 50 equals 5x plus 60. Solve. Subtract 5x from both sides. Gives us x. Subtract 50 from both sides. Gives us 10. So we find that x equals 10. If we plug this in, that would show us that this is 110. And this would be 30 plus 50, 25, which is 55, which makes sense. 55 is half of 110. Okay, so the relationship stands, and we're good to go. Okay, so talked about those inscribed angles, and now let's talk about inscribed angles formed with a tangent line. Okay, the measure of an angle formed by a tangent line in the chord is half the measure of the intercepted arc. The measure of an angle formed by a tangent line and a chord is half the measure of the intercepted arc. So if you notice this diagram over here, for angle CBD, which has a vertex of B, that's the point that's on the circle, the intercepted arc is arc BA. BA, notice here and here. Okay, that's where our arc goes. Okay, therefore, CBA, because BA is 148, since it's half of the intercepted arc, is 148 divided by 2, which gives us 74 degrees. So the measure of angle CBA is 74 degrees. So again, the more difficult part is just understanding what the intercepted arc is and then applying what we have already. So, number one, let's look at some problems down here on the bottom. Okay, they gave us that this arc is 220. We want to find the measure of angle X. We should be able to see that the intercepted arc here, because this line is tangent, is half of this arc. So the measure of this angle is half of this arc. So if this is 220 and the circle is 360, that means the rest of this has to be 140. So if this arc is 140, we have a tangent line and a chord, so this should be half of the arc it intercepts. So X will be 140 over 2, or 70. Second example down here, we have a triangle in here that makes this a little bit easier for us. A few different ways that we can do this. Again, remember that when you're given variables, that is not a prescription or necessarily a prescription on which variables to solve first. So it's not that we are necessarily forced to go X, Y, then Z. And I know that I did not do that in solving this problem. In solving this problem, I first noticed, hey, this is an isosceles triangle. We see that these two chords are congruent. In an isosceles triangle, if the two chords are congruent, or these two sides are congruent, then I know their base angles are congruent. And so, since this is 54, we can do the problem 180 minus 54, and that gives us 126. And so divide this by 2, because 2y will equal 126. We can find that y is 63. Okay, that didn't have very much to do with the inscribed angles up to this point, but now we will get to those inscribed angles. Okay, and kind of come back to what we've been talking about. But in geometry, it's always important to keep what we learned in the toolbox so that we can use it later. So now we know that this angle is 63. It is an inscribed angle, and it intercepts this arc. This arc here then will be 126. 63 times 2. We have a chord and a tangent line, and that angle is X. Okay, remember that a chord and tangent line will be half of the arc it intercepts. So for X, angle X, we have half of 126, which is 63. Find that X is 63. Okay, now there are a couple ways that we can find Z. One way is that, hey, this is a line, these all three should add up to 180. But to go with the inscribed angle practice here, notice that 54 intercepts this arc. So 54 is an inscribed angle, intercepts this arc. That means this arc should be double that. 108. The tangent and the chord, so chord and the tangent here represents Z, should be half the arc it intercepts. Half of 108 is 54. Okay, and so there we have it. And then finally we have BC and angle B in this last problem. Again, anytime you feel comfortable, you can pause it and then just try to fast forward and see what I got it and see if it matches what you have. And if not, you can listen and walk through it with me. So they want us to find the measure of arc BC. And so a couple ways we can do this. And one way I want you to notice is that we're given a diameter. Okay, it goes through the center of the circle. So we know that all this together is 180. Also given an inscribed angle. Here, this is 51, and so that means this arc must be double that, or 102. So since this whole thing is 102 and we already know that arc B is 72, that must mean that arc EA is 30. Okay, just writing that out. So here we have it. Arc EB is 102. Arc EBC, or EC, however you want to think of it, is 180. And so 102, or 180 minus 102 should give us what arc BC is. In this case, that's 78. So arc BC is 78 degrees. Okay, and we don't have to question whether it's length or measure because it says measure here. All right. Now we got to find angle B. Again, what we're going to do here is angle B is an inscribed angle, and the arc that it intercepts is here, AEC. AEC. And so again, we already identified that we have a semicircle. EDC is a semicircle, 180 degrees. AE is outside of that semicircle, so 180 plus 30 gives us 210. Since angle B is the inscribed angle, it's half of that, which is 105 degrees. Okay, so we talked about inscribed angles using two chords and inscribed angles using a chord and a tangent. Okay, in both cases, the angle is half of the intercepted arc. Okay, done a lot of practice with that and solved for some variables, so hopefully you are able to do the same thing. All right, see ya.